Okay, going to be working here on the homework assignment for 10.4, which is the section on the cross product. And start out with number 1. To find the cross product, I'm going to give you two vectors here. A is the vector 6, 0, negative 2. The vector B is the vector 0, 8, 0. All right, so let's remember how we do this. Line them up, one on top of the other is the easiest way to write them so that you can do this little shortcut. I, J, K. So what we're going to be trying to do is we're going to figure out what I is, then what J is, and then what K is. And we're going to try and find these coefficients in front, remembering that this will be a minus. So let's do this. What we do to find out what I is, we cover up I, and then we do the determinant on this little 2 by 2 matrix of numbers. So 0 times 0 gives us 0, and then we subtract from that 8 times negative 2. 8 times negative 2 is negative 16. So we're going 0, then minus negative 16 is positive 16. And now to find out what J is, cover up the middle, and we do this 2 by 2 matrix. 6 times 0 is 0, minus 0 times negative 2 is still 0, so it's just going to be 0. And then for K, we cover up these two, and we do 6 times 8, which is going to be 48, and then we subtract from that 0, so it's just going to be 48, so positive 48. And so we get the vector 16, 0, 48. All right, next problem. Let's see, number 2. I can just erase some stuff in here. For number 2, same story. So I'm going to have I minus something with J, and then K, like that. So the numbers, or the vectors are 1, 1, negative 1, and 2, 4, 6. All right, so if I'm going to find out what the I component is, I cover up the I here. 1 times 6 is 6, and then I'm going to subtract from that 4 times negative 1, which is negative 4. So that's 6 plus 4, which is 10, so I'm just going to put a 10 here. And then to find out J, I do this. So 1 times 6 is 6, and then minus 2 times negative 1 is negative 2. We add those together, we get 8, but then we're going to subtract it, so minus 8. And then to get K, cover these up, 4, and then minus 2, which is 2, so positive 2 here. So the answer for the cross product would be 10, negative 8, 2. Let's see, 3, I'll let you work yourself. Just remember on 3, the vector B. On 3, the vector B is actually negative 1, because I have negative I. I don't have a J in there, so 0, and then the K is 5. So just keep that in mind when you do that, number 3. Of course, the I is different. I'm sorry, the A is different, but I don't see any issues. Let's do number 6 and number 7. Number 6. Okay, so they give you a vector A, and it looks kind of weird. It's Ti, which is just, I'm sorry, yeah, I'm doing it right. T, the T is for the I component, cosine T for the J component, and sine T for the Z component, which we have there. And then B is the vector, see there's a 1 in front of I, negative sine T here, and cosine T here. And I'm going to try and do a cross product. So I'm going to get I minus something with J and then K. So to figure out, this is I, J, K. Figure out what I is, I cover it up. Cosine T times cosine T is cosine squared T. And then minus, and then negative sine T times sine T is negative sine squared T. And that's cosine squared T plus sine squared T. That's just 1. That's Pythagorean identity from pre-cal. So I've got 1 there. Now to find the J, cover up J. T times cosine T is T cosine T. Minus, and then 1 times sine T is just sine T. And I'm going to subtract that. So what's going to happen here when I subtract that is it's going to change the signs. It's going to make that positive and that negative. So I'm going to write it this way. Plus sine T minus T cosine T. That's sitting in front of J. And then plus, let's see, now I'm going to find out what the K is, so I cover this up. I have T times negative sine T, which is negative T sine T. And then I have minus 1 times cosine T, which is just cosine T. And that's going to go right here. So negative T sine T minus cosine T, and that's in front of K. So the vector, right, A cross B, is the vector 1 sine T minus T cosine T, and then minus T sine T minus cosine T. So that's number 6. Oh, you know what? I didn't notice in the instructions. I'm supposed to verify that these are orthogonal to A and to B. I didn't do that in previous examples. So let me let me now, for this example, verify that this is orthogonal to A and B. Well, you know what? What I'll do 1, and then we'll come back to this one. So on number 1, sorry about that, I should have read the instructions. I had that the vector A was the vector 6, 0, negative 2. And then I had the vector B was 0, 8, 0. And A cross B was, what did we get there? We got 16, 0, 48. So now I'm going to verify, okay, I want to show that the vector A is orthogonal or perpendicular to A cross B. So to do that, all I need to do is show that A dotted with A cross B equals 0. If I can show their dot product is 0, I'm done. So I'm going to take the vector A, and I'm going to dot it with the vector A cross B. So if I do 6 times 16, that's 60, it's 96, plus, let's see, 0 times 0 is going to give me 0, and then negative 2 times 48 is negative 96, and that equals 0, and that checks. Now, I also need to show that B is orthogonal to A cross B. And so I want to show that B dotted with A cross B is 0. And so now I'm doing, instead of A, I'm doing B right here, dotting these two together. So let me dot them. I get 0, 0, 0. So that's true. All right. So I'm not going to do it for number 2. But let me go to 6. So 6, this is what we got for our answer right there. That's A cross B. Now A was the vector t cosine t sine t, t cosine t sine t, and B was the vector 1 negative sine t cosine t. So let me show first that A is orthogonal to A cross B. So I want to show that A dotted with A cross B is 0. So let me show that that's true. So let's dot these. Let me actually multiply A here by A cross B, so dot product. T times 1 is T, plus cosine T times this. So when I multiply cosine T, I have to distribute it to each of these. So I get cosine T, sine T. Then I multiply this by cosine T, so I get minus T cosine squared T, because you have 2 factors of cosine. And then plus now sine T times this. So when I multiply this times sine T, I actually get negative T sine squared T. And then when I multiply this times sine T, I'm going to add a room here, minus sine T cosine T. And I need to show that that's 0. So to show that 0, first of all, notice that this and this cancel. And then on this one, these two, I can factor a negative T out. And when I factor a negative T out of both of those, I get cosine squared T plus sine squared T. Then back here in the front, I had a T plus, and then this. So this is a 1. Oh, that's 1. So this just becomes T, right? Plus minus T is minus T, which is 0. So it checks. Now, I still have to show that B is orthogonal to A cross B, so I'd have to show that B dotted with A cross B is 0. I'll let you do that on your own, but you get the idea of how it's done. Okay. Moving along. I'll let you do number 7 on your own. Number 8, it says if A is I minus 2k, so I minus 2k is this, and B is equal to j plus k, so that's j plus k. It says find the cross product, sketch A and B and the cross product, all with vectors all starting at the origin. So let's find the cross product first. Okay, so I'm going to try and go a little faster here. Covering up this, I get 0, and then minus negative 2 is 2. So I'm going to get a vector that's going to be 2. And then I cover up the middle. I go 1 times 1 is 1. 0 times negative 2 doesn't matter, so I get just 1, but then I have to subtract it, so minus 1. And then cover up this, I get 1, and then take away nothing, and that's just going to be 1. So there's your cross product. And now I want to sketch these. Okay, this is X, Y, Z. So let me sketch A. I'm going to go out on the X, 1, nowhere on the Y, and then down 2, 1, 2. So from the origin down to here, that's vector A. Vector B is 0, 1, which moves me here, and then up 1, which puts me about here. That's B. And then the vector 2, 1, 2, negative 1, which is over here, and then up 1, which is here. That's A cross B. There we go. All right, this is, which number was that? Number 8. Okay. Number 9. Find the vector not with determinants, but by using properties of cross products. Okay, so number 9. Let me show you how to do number 9, and then maybe you can get the rest. So 9, you have, they're giving you that I cross J cross K. So I hat cross J hat, and then cross that with K hat. And they want you to find out what this is without actually doing any computations and just using properties. So the properties, let's see, the properties are on page 561. So just using this right here on page 561 on the bottom is equal to K. So you're crossing K with K. And then if you flip over, where is it? They don't have K cross K. Oh, okay. So the property's not listed, but in example 2 on page 559, they show that A cross A is 0 for any vector, any non-zero vector. So we can verify this real quick. If I take some vector A, A1, A2, A3, I don't know what it is, as long as it's a non-zero vector, and I cross it with itself, let's see. Let's show that it's always going to be 0. So we cover this up. You get A2 times A3. So the cross product will be equal to A2 times A3 minus A2 times A3. Well, it's gone, isn't it? And then the next piece will be A1 times A3 minus A1 times A3. So it's 0 again. Then you subtract it. So this is 0, next one's 0, cover up this one, A1 times A2 minus A1 times A2 is 0 also. So you're going to get 0 the whole way. So you can get the 0 vector. So this right here is this, but this is 0 vector by this. Oops, 0 vector. So let's see if that's enough for you to be able to do. Yeah, I'll let you do the rest, 10, 11, 12. See what you can do. Just use the book. 13, I'll let you, well, I'll do 1 of 13. So they're asking you if this is meaningful or not. So let me do A. So does this even make any sense? A dotted with B cross C. Well, we know that A is a vector, and I can only dot vectors with other vectors. The question is, what is B cross C? Well, B cross C is a vector, right? And so I'm going to dot a vector with a vector, and that's doable. So that makes sense. Let's look at one that wouldn't make sense, if I can find one. Okay, look at E. We have A dot B crossed with C dot D. So when you dot two vectors together, you get a number. And then I want to cross that with dot two vectors, you get a number. You cannot take the cross product of two numbers. You can take the cross product of two vectors, but not two numbers. So this doesn't make sense, all right? I don't know if they want you, see what the book says they want you to answer that, how they want you to answer that. What was that, 13? Yeah, okay, so they just say this is meaningless, okay? This has no meaning to it. See if you can do the rest of those on your own. All right, so where am I at here? 14. Let me do 15. They give you a picture. Okay, you've got a vector u like this, and you've got a vector v like this. They tell you that the magnitude of v is 16. They tell you that the magnitude of u here is 12, and they give you that the angle between these is 120 degrees. And they ask you to find u cross v, the magnitude of u cross v. And then they also ask you, is u cross v coming out of the page or into the page? So first I'm going to notice that this is the tail, this is the tip, this is the tail, this is the tip. So I need to try and put the two tails together. So let me redraw this. I'm going to leave v alone. I'm going to move u up here like this. Okay, and the magnitude of u is still 12. But now this angle, instead of being 120 degrees, is now 60 degrees. And remembering that the magnitude of the cross product is the area of the parallelogram formed by these two vectors. So I'm going to erase this now. So we're actually going to find the area of that. So we have a formula for the area of the, the magnitude of the cross product. It's very similar to the dot product formula. It is that the magnitude of A cross B is equal to the magnitude of A times the magnitude of B times sine of the angle between the two vectors. So I had to get theta. Theta is 60, not the 120. So we had to go tail to tail before we could figure out the angle. So I know for this one, the magnitude of u cross v should be equal to the magnitude of u times the magnitude of v times sine of, well, 60 degrees. I know the magnitude of u was 12, and then I know the magnitude of v was 16. And sine of 60 degrees off your unit circle, you're up here at 60 degrees. Sine is the y-coordinate, which is going to be √3/2. So let's see how I'm going to do that. I'll just reduce one of these. I'll make that an 8. So 12 times 8, 80, 96. So 96 times the √3. So there's your magnitude. And the next thing is to determine whether or not it's coming out of the page or into the page. So remember with cross products, if I have two vectors, u and v, right? So let's say that's u, and this is v. Then if I cross u and v, I get my right hand and I put my fingers out towards the direction of u and make sure that their tails are attached together. And my fingers go out towards u and I curl my fingers towards v, and my thumb shows me the direction of the cross product vector. So that would go into the page in this case. But up here, well, yeah, that's what we have. If I put my fingers out in the direction of u, and I curl my fingers, notice I'm not going towards the vector v. So I need to turn my hand over. I need to curl my fingers from u, okay, towards v, so my thumb is pointing into the page. So this is going into the page. Okay, that's it for number 15. I'll let you do 14. All right, so 16 is a picture that I'm going to have to draw here. So here's what they have drawn. Z, X, Y. They have a vector A and a vector B. So A is coming out this way, looks like. Okay. Vector B is going up like this. And the question is, oh, they also give you some other stuff here. The figure shows a vector A. That A is in the xy plane, so it's on the ground. The vector B is in the direction of k hat. Now k hat is straight up, so B is pointed in the same direction. The length of A they give us is 3, and the length of B is 2. And they ask us to find, first of all, the magnitude of A cross B. So what's the magnitude of A cross B? Well, that's the magnitude of A times the magnitude of B times sine of the angle between them. Magnitude of A is 3, magnitude of B is 2, sine of the angle. So what's the angle in here? Well, if this one's pointed straight up and this one's on the xy plane, then the angle between them is actually a right angle. It's 90 degrees. So that means we need sine of pi over 2, right? And sine of pi over 2 is going to be 1. So your answer is just 6. That's part A. Sorry, this was part A. The next thing, part B, use the right-hand rule to decide whether the components of A cross B are positive, negative, or 0. So what are the components of A cross B? So what I want to do is I'm going to try and get my fingers and point them out in the direction of A. All right, and curl my fingers towards B. So using my right hand. So I think maybe I could do it this way. My fingers are on the XY plane with A, pointed in the direction of A, and if I curl my fingers, I curl up towards B. So my thumb is going to come out like this. So my vector, the cross product should come out this way, right? That should be A cross B. And that means that it should be still on the XY plane, it's still on the ground. And it's, let's see, the X coordinate, okay, I have to come out to get to that vector. So the X coordinate should be a positive number. The Y, I said coordinate, component. The X component should be positive. The Y component should be negative. And the Z component should actually be 0. So it should still be on the XY plane. So let's just double check that. Y component is negative, X component is positive. Doesn't ask about the Z component. Oh yeah, it does say the Z coordinate is 0. So yeah, that's it. All right. So now we move on to 23 through 31 odd. So 23, prove property 1 from theorem 8. This is property 1, theorem 8. I want to show, I'm only going to do one of these, okay? Number 23. So I want to show that A cross B, right, equals negative B cross A. So let me show that that's true. So let me start with this side over here. Let's assume that A is some vector A1, A2, A3, and B is some vector B1, B2, B3. Then A cross B should be equal to, this is going to be kind of ugly, cover this up, it's A1, B2 minus A2, B1, and then cover up the middle, A1, B3, A1, B3 minus B1, A3, so I'll put A3, B1. And then we have to subtract that, so it's going to make this minus and that plus. So this will be minus A1, B3 plus A3, B1. And now I get the last component, I cover this up, A1, B2. Did I mess up that first one? A1, B2. Oh shit, hold on. This one right here, oops, brain fart. I should have covered up this one. This one was A2, B3 minus, and then B2 times A3, so A3, B2. I'm just putting the A's before the B's. All right, now this one, cover up that, A1, B2, and then minus these two, so A2, B1. Okay, that's what A cross B is. So what is B cross A? Well, B cross A is what you have to flip the order of these. So I'll do it this way. I'll just write B above this. So B1, B2, B3. So let's do the first part. Cover up this one. B1 times A2, that's A2, B, right, cover up this one, you get A2, B1, minus, God, I did it again. I don't know why I'm doing this. Okay, try to get the first component, the I component. Cover up the I component. B2 times A3 is A3, B2. Cover this up. Minus A2 times B3, so minus A2 times B3. All right, now cover up the middle one. And you get B1 times A3 minus A1 times B3. But because it's the middle component, you subtract it, so minus and plus. So I'm going to put how should I do this? I'll do it A1, B3 minus A3, B1. Now I'll cover up the last one. B1 times A2, which is the same as A2 times B1, minus A1 times B2, so A1 times B2. So these are not the same, all right? But notice A2B3, negative A2B3, negative A3B2, positive A3B2, and then everything else is the same. They're just off by a sign. So if I change this to negative, it changes that to negative, that to positive, that to negative, that to positive, that to negative, that to positive. And now these match. Every component matches. So you can see that these two are equal. So that shows the first identity, or the first property. So 24, 25, 26 are the same way. Oh, I gotta go. Wow. All right, so I was able to get through just up to 23 is where I stopped.